All right, this is the second part. What did we do? Trapezoids before we did kites or something? I forget. Is that what it was? I think the whole lesson was trapezoids and kites. So now we're going to do the kite part. And I think we've talked. No, we haven't talked about kites at all yet, have we? Have we even mentioned them? I think we did. What did we say about the kites? What did we know about the kites?
That they had two.
By the definition. Yeah, we did.
They had two something. Two parallel.
They got two something.
Quadrilateral with two pairs of equal consecutive sides, with these opposite sides of line.
Good. She wrote it down. All right, so let's draw what a kite looks like. Wait till Tim comes back. Only one at a time. I'm just going to draw this line right here for reference. For right now, we'll talk about it in a little bit. But it's not going to be perfect, but I'll try to make it as accurate as I can. And this goes to here. That's pretty good. Kind of looks like a kite. Let's get rid of that thing in the middle. All right, by definition, what do we know about this? We know that, I'll tell you what, let's put some letters in here. Let's go W, X, Y, and Z. So Lillian, what did you say? Don't read it word for word. Just tell me in your own words after you read all that. What's equal here by definition? No, I don't want you to read it. I want you to tell me what's equal here. Tim, have a seat.
The two sides.
No, I asked Lillian.
Say something.
Well, can you give me a second?
She's got to look at it first. What's equal to what? Give me letters. WZ? All right, what's it equal to? Good. Because they're what? Because, what's your definition say? They are what to each other? They're consecutive sides. That's right. Everybody listen, please. Logan, get your chair down on the floor. Sit up. You taking notes? Looks like the only thing you have on your desk is what I handed out. All right. So these are consecutive sides. What does the consecutive sides mean? It means they're right next to each other. So they're not opposite sides. So the opposite sides on a kite are definitely not equal to each other, okay? This is just by definition. This is something that we learned a little bit ago, right? Lesson or two, maybe something like that ago. So we learned that these two sides are equal. There's something else that's equal by definition. What else is equal? Give me letters. Name stuff. Now you can do this one, Tristan. Okay, XY is equal to what? What is it? ZY. Good. All right. So it has exactly two pairs of consecutive congruent sides. Is that what? Yeah, the definition said something like that, okay? So by definition, that's what we know. Well, today, we're not just going to do the definition. I think that's about the only thing that we knew about a kite, isn't it? We didn't learn anything about the angles, did we? I don't think so, because that's what this theorem says. So we have a theorem. I'll just write down theorem. All right, that says something a little bit more specific about the kite. All right, and what it says that it has exactly, I'm not going to write down it, but you can write it down if you want, exactly one pair of opposite angles are equal to each other in a kite. Exactly one pair are equal. So which pair? Is it W and X? Is it X and Y? Is it Y and Z? Is it W and Z? Which ones are they? Is it X and Z? Is it W and Y? I think I hit all the combinations there. Which ones, just by your gut feeling, just by looking at it, which ones look like, in this situation, like they're equal to each other? X and Z. And that is absolutely true. That is correct. All right, so X and Z are equal to each other. Now watch this. We're going to do a little bit of a proof here. Is that all right? It's not a full-out formal proof, but we are going to take a look at it. So check this out. I want to look at this, and I want you to tell me why. Now, the theorem says it, but what can you always do with theorems? You can always do what to a theorem? No. Postulates are just accepted as fact. Right. Theorems you can prove, right? So we want to prove that this angle x is equal to this angle z. That's what we want to prove, okay? So we don't know that that's true just yet. Everybody understand that? So what do we know? Well, I got two triangles here, don't I? Didn't we have a chapter about triangles being what to each other? Congruent to each other, right? Triangles aren't corresponding. Parts of triangles are corresponding, right? The sides can be corresponding. The angles can be corresponding. But the sides or the triangles themselves are not corresponding. They're what to each other? They could be what? Could be what? Yeah, we don't say equal though with triangles. We say they're congruent to each other. That's correct. So these two triangles could be congruent. Let's see if they are. Well, this one has a side, and this one has an equal side. This one has a second side, and this one has a second equal side. So right now, I got two sides. Remember, I don't know that x and z are equal to each other, so I can't say side, angle, side. You understand that? Because I'm trying to prove that angle x and z are equal to each other. So I don't know that x and z are equal to each other, even though I just wrote that down. Tell you what, let's just get rid of those for right now. I'll write them in a second. But look, this is what we have right now. That's our information. We have a kite. And I drew a diagonal from W to Z. So if these two sides are equal, these two sides are equal, what's true about the red one, the WY? It's not parallel to anything. It's not really mid-segment, but it's a side that's shared by both of these triangles. Would you agree? Yeah. This triangle has that side in it. Agreed? See, triangle WXY, it's got this side WY. And this triangle down here, WZY, that has that side. So what's true about WY? It's equal to what? Itself. That's right. You've seen that before, right? We've talked about that. We just talked about that in my other CP class. And we're considerably further ahead of them. So I think it was chapter 4. So we talked about this in chapter 4. Now, let's take a look at this triangle and this triangle right here. What do I know about those two triangles? Side, side, side. That's right. That means the triangles are what? Congruent to each other. So the triangles are congruent to each other because of side, side, side. Which means those two triangles, if I took them and I just flipped them, not flipped them, but like, folded them. Good. Folded them, right? Right at that line. That's my fold mark right there. Then X and Z would correspond to each other, wouldn't they? All right. So if these two triangles are if these two triangles are congruent to each other, then the corresponding parts, right, the parts that match up, have got to be equal to each other as well. Agreed? So that means that if these two triangles are congruent to each other, that means that what? Angle X is equal to what? Angle Z. Why? Because they correspond to each other. Everybody see that? So if you have two triangles and they're congruent to each other, all the other parts have to match up as well, right? So those two would match up. What else would match up? These two right here, wouldn't they? Yeah? And what about these? Those two angles right there would match up with each other as well, all right? So why do we do all that? We did that just to show that angle X is equal to what? Angle Z. All right? And that's we just basically did a proof. Okay, at the beginning of the year I said, okay, we're not really going to do proofs, but that is a proof. We proved that these two triangles are congruent, and if the triangles are congruent, then the angles that match up, that correspond with each other, they've got to be equal to each other as well. Everybody good with that? All right, I think that's kind of good. Let's do another one. Let's, I like that picture. I don't want to redraw it, so let's just draw this in here. I'm going to make another diagonal. What's another diagonal I can make? From where to where? X to Z. So let's do that. From X to Z. Right there. Now, there's a couple things that's true about that diagonal. Put it in a different color just to make it stand out a little bit. Okay? First of all, that yellow one, again, normally I wouldn't want you to do this, but I want you to just look at it and think a little bit because it kind of like just pops out at us, all right? We can see it. Look at this yellow one, XZ, and look at the red one, WY. How does it look like they meet each other? At what kind of an angle, I should say? just by looking at it. Now, again, that's not the best way to go by things. It's just by looking at it. But I just want you to see it. What does it look like? What about the angle between the yellow one and the red one? What does it look like? Looks like it's 90 degrees, doesn't it? Okay, or what? A right angle, or the lines are perpendicular, right? Everybody see that? It looks like it, right? And it is true. It is very true that they are. And that's one of our other theorems. So we have another theorem that says that the diagonals of a kite, what do you think is true about those two diagonals? They're what to each other? They're perpendicular. And that's what the theorem says. The theorem says that the diagonals of a kite are perpendicular. We could go through and try to do a proof on that one as well. We're just not going to. Just remember what it is. I'm not going to write it down, but you should. It says the diagonals of a kite are perpendicular. So that means XZ, I'll just write this. XZ, line segment, XZ, is perpendicular to line segment WY. All right, that's basically what the theorem says. And this one right here, that's basically what that theorem says. It's just not all in words, all right? There's one more thing that's true about those two diagonals. By the way, they give them fancy names. We haven't learned the fancy names yet. And in fact, I was teaching a little bit about kites to my other class, and I forgot one of the names. I was like, man, what is it? And then I looked at my notes. I'm like, oh, I should have remembered it. I did remember one of them. This one right here, this yellow one, I'll write it in blue just to give us some extra color. All right, this one right here, they call that the crossbar. We don't really refer to this very often. We don't really deal with kites a whole lot. Every once in a while we do, but not a whole lot. Why did I put S? It's just a crossbar. So XZ is considered the crossbar, and this one right there, the one that goes from W to Y, I'll tell you what, crossbar would be XZ, line segment XZ, and then line segment WY, they call the axis of symmetry. That's a word you're going to use in other math classes. It may not mean what it means right here. Okay, yeah, in Algebra 2, they talk a lot about the axis of symmetry. Okay? It has to do with this. You want a little sneak preview, Algebra 2? So, like if you had an X and a Y axis, and you're going to be looking at stuff that looks like this. Okay? So you're going to be graphing shapes that look like this. We're not just going to be graphing straight lines the rest of our lives, okay? We'll be graphing stuff that looks like this. Do you see this? I'll put a dotted line. Or it's the axis, the y-axis itself. Do you see that? They usually denote it by a dotted line. That right there would be considered our axis of symmetry. Why? Because it splits that thing. See how it's like a bowl, like a U kind of thing? What does the axis of symmetry do? It splits it basically in what? In half. Okay? And that's kind of what this is doing, isn't it? That red one is basically splitting that whole entire kite in half. That's the axis of symmetry. Don't know why I moved that way over there. Let's move it a little bit closer. Boom. There we go. All right? Just put it right there. Thanks. Everybody good so far?
Yeah.
So what were we on? We're doing this yellow thing, right? So there's two things that's true about this, this crossbar right here. It's perpendicular, and it's actually, what do you think is true about, what letter? I don't know, let's use a letter. Let's use P for point, okay? At P right there, what do you think might be true about that yellow line, that crossbar? What do you think that red one, that axis of symmetry, does to the yellow one? It's perpendicular, but it splits the yellow one at its midpoint. Or it does what? Give me a good geometry word. When a line is being split right in the middle, or a line segment is being split in the middle, we say that that line did what to the line segment? And not just intersect, it bisects. It's more specific than just intersects. It could intersect anywhere, right? But if it splits it in half, then it bisected it. Bi meaning what? Two. Split it into two equal parts. So tell me something about XP and ZP. They're equal to each other. So XP, or you could say they're congruent to each other. I'll put ZP. All right? So this theorem basically has two parts to it. So these diagonals of a kite, this little crossbar right there, okay, two things happen to it. First of all, it's perpendicular to the axis of symmetry. Secondly, that crossbar is being bisected by the axis of symmetry. A lot of new words, right? But a lot of old words too. Bisect, we know what that means. All right, we know perpendicular, we know right angle and all that stuff. Okay, so really the only thing new that we learned is this word crossbar and axis of symmetry. But you know which one. Got it? The crossbar always goes from one equal angle to the other. Everybody see that? All right, so I would not call this the axis of symmetry. The axis of symmetry goes from the two unequal angles. You see big angle W right here and big angle Y? They are not equal to each other. And you cannot have a kite with like two sets of equal angles. You can only have a kite with one pair of equal angles. Make sense? Okay, so a kite, you only have one pair of equal angles. And that's where the crossbar is. It goes from one angle to the other equal angle. Make sense? Yeah, that's not too hard, is it? Let's do an example and we'll be done.
I have a question.
Yeah,
On the quiz,
yeah.
like, you're gonna,
There's no quiz.
like, for, like, on 2 lines, are you gonna, like, is there any, like, difference or no? Like, which one's the bisecting line?
No. No, because you'll know what sides are equal and all that kind of stuff. All right. The equal angles are always between the two unequal sides. You see that? That's got one mark. That's got 2 marks. The angle between it, that's going to be the angle that's equal to the angle between the other two, right? Unequal sides. See this? This is between 2 equal sides. That big angle is not going to equal the angle between the other 2 equal sides. You got it? It's only the one between the 2 unequal sides that are equal to each other. All right, so it's not going to be color-coded on the quiz or the test once we have it. All right, you just have to know which one is the crossbar, which one's the axis of symmetry. Everybody got it? Okay, so now let's draw a kite. We're going to draw it a little bit differently. Instead of side to side, we're going to draw it kind of up and down. I always like to start with the axis of symmetry first. That helps me line things up a little bit better. So I'm going to draw, actually, let's do this. Let's draw a crossbar as well. There's a nice cross. Let's get it in the middle. Right, there's your biblical integration. They always tell us to do biblical integration. There it is. There's your cross, okay? And we are going to go from here to here, and then we're going to go from here to here. So that way, if you do something like this, then it makes it kind of easy to draw a kite. Just connect all that, and that should be a fairly accurate kite. All right, if I draw 2 perpendicular lines, and then just connect the outsides of them, and you got yourself a kite. So let's label it. Oh, look at this. They label this. They're being kind of fancy here. What do you think they labeled it? Yeah, it's a kite. K-I-T-E. So that's what they used. All right, so here's what they tell you. This is an example. It's example 4 in the book. So example 4. They tell you some stuff. First of all, they tell you that it's a kite. All right, so here's how they write it. It's kite. There's no like symbol for it. You know how you have a symbol for a triangle and a symbol for a parallelogram? There's no symbol for a kite. We just write the word kite. So it's kite what? K-I-T-E. So it's kite, kite. All right, and they tell you something else. I'm just going to write it the way they tell you, and then we're going to mark it in the picture. It's X-K-E. X-K... Oh, X. It's not an X. Wait a minute. Oh, yeah, X is right here. Boom. That's an X. K-E. It's 55 degrees. And they tell you one more thing. Yeah, we won't worry about that. Okay, this is what they tell you. So now, here's what they ask you to find. They want you to find angle KTE. Just put it right there. Thank you. And then they want you to find TXE, angle, and KEX. Oops, let's put the angle symbol. Angle KEX. And one more, part D, they ask for angle KET. All right. So that's what they give you. So let's mark it on the picture. All right. Well, you know it's a kite, first of all. So what can we mark on this if it's a kite? I can say that Ki is equal to what? IT or Ti, right? And then you can say that Ke is equal to Te, all right? And you know that this little bit right here is going to equal this little bit right there. I don't know if we'll use that or not on this particular one. Doesn't really look like we are, but it's good to mark the stuff up, all right, that we know. And you know it's a kite, so you know the diagonals are no, diagonals are not equal. They're perpendicular to each other. Okay? Everybody got that? And you know some angles are equal. What angles do you know are equal to each other? Let's do the angles in a different color. Too much red. So big angle K, that whole big angle right there, and what else? That whole big angle T. Technically, it's angle IKE, but we'll just say big angle K and big angle T. All right, let's find this one first. Angle KTE. Let's find KTE. There's K, there's T, there's E. So it's this little bit right there. That's what we want to... Oh, did I forget something? Oh, I didn't even put in the 55. Let's do that. XKE, where's that? XKE. So this is 55 right there. Okay? Everybody see that? Yeah. I was going to say, how in the world can you find that? You got to know something first. Yeah, so you know that's 55 right there. So now, what's this angle right here? KTE, KTE. Yeah, it's exactly the same. Look at these two triangles right here. Do you see those two triangles? What do you think might be true about them? Oh, triangles aren't equal. Triangles are what? Congruent to each other, right? So are they congruent to each other? Sure, look, I've got a side, and guess what else I have? I got this side. So yeah, these are congruent because of side, side, side. So if I took them and folded it, then this angle right here would match up with this angle right there. So how many degrees is that? That would also be 55. You always need to back up your reasons. You really shouldn't look at it. I mean, you could still get the right answer even if you didn't back it up. But in your head, you should be able to back it up and say, why are they equal to each other? And that's why, because these are congruent triangles. Those are corresponding parts of congruent triangles. And that's why that's 55. All right, let's keep going. TXE, where's that? TXE. Oh, that's an easy one. What's that? Right where the X is. It's 90 degrees, isn't it? Because if that's 90, right next to it is got to be 90. Because 90 and 90 is 180. Makes a straight line, so that's 90 as well. So that was easy. That's 90 degrees. KEX. 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 This one down here. Let's do this in a different color. So KEX, that's this one right here. It's not too hard. You got to do a little math, not too much. What? What math do you do?
145, 180 minus 145.
145? Where's 145? I'm not saying you're wrong. I'm just saying, where's a 145? How'd you get 145?
Well, because we know it's a 90 degree angle.
Yeah.
We know it's 55.
And what'd you do with those? Okay, that's it. All right? Everybody see that? Or, here's an easier way. You could do it that way. You could go 180 minus 145. You could do that, right? But this is a right triangle, isn't it? What's always true about the two non-right angles on a right triangle? They are always what? They always add up to be what? 90 degrees. So instead of going 180 and then adding these two together and then subtracting, all I got to do is what? 90 minus 55. Not saying your way is wrong. I'm just saying this is just a little bit easier. Okay? We all want to do things a little easier, don't we? Yeah, me included. All right? So on a right triangle, you always know that the other two acute angles will always add up to 90. So you don't have to go 90 plus 55 is 145 and then take that away from 180. All right? You just go 90 minus 55. And what is that? That's 35. So this would be 35 degrees. Make sense? Angle KET. Yeah, that's it. KET. Where's that? KET. Oh, it's this whole big one right here. It's that whole big angle. Let's do that in a different color. Let's do a different color. All right, so let's do that whole big angle right there. Well, you already found the little blue one, right? That's 35, and then this one's going to be exactly the same because these are congruent triangles, right? They're corresponding parts. This is 35. This is 35. And Caleb said it. How'd you get 70 out of it? Added them together. Okay, and you get 70. So that's 70 degrees. And there you go. There's one more they give you. I'm not going to do that one. Make sense? This is very common stuff. Haven't we been doing this kind of thing? Yeah, we've been doing this kind of thing, except before today, you didn't really know that the opposite angles were equal to each other. You didn't know all that kind of stuff. But now we do, all right? And now you should be able to figure it out. Have you gotten into maybe a little bit of a routine with geometry? It seems like we do the same kind of stuff, don't we? All the time, except we just do it with different objects and different figures. Would you agree? All right. I mean, stuff that we did with triangles, we're kind of now doing with parallelograms, and the same kind of stuff we did with parallelograms, you're doing with rectangles and trapezoids and kites and rhombuses or rhombi. Okay, that's the plural. All right. So, yeah, I mean, after a while, you're like, yeah, I've kind of done this before. It's a different picture, right? There's a couple different things that I know now that I didn't know before, but I'm really, the math and setting it all up is all kind of the same. What does it basically boil down to? It seems like it boils down to either things are equal to each other or things are supplementary, right? In this case, they were complementary. What does that mean, complementary? It means they add up to what? 90, right? Complementary means they add up to 90. Supplementary means they add up to what? 180, good. All right, anyway. I just think it's good to see that because I don't know if that helps you or not, but it just shows you that we're kind of doing the same thing, you know, chapter after chapter, we're kind of, not exactly, but kind of doing the same thing over and over again. All right, well, what did I have you do with this? 18 to 25? So, yeah, we got 10 minutes. So 18 to 25. Don't use this as a slack off time. Don't use it as a time just to sit and talk. Okay? When it's like 2 minutes till class is over, don't have me come over and say, why aren't you working? We only got 2 minutes left. Well, we got 10 minutes now. Okay? So start working right now. Everybody got it? It's that section. It's section 4.5, or 6.5, I'm sorry. 6.5. Page what? 281, 282.
What numbers is it?
Oh my gosh, it's right on the screen. All right, so there's your homework. Section 6.5. Is it B or just regular? It is B, yep. So it's 6.5B. So have that done for tomorrow, please.